What if I told you that everything you've been taught about our planet, everything you see when you look up at the night sky, every photo from space you've ever admired, might be part of the most elaborate deception in human history? What if the ground beneath your feet isn't spinning through space at thousands of miles per hour, but instead rests perfectly still on a vast flat plain? Tonight, we're diving headfirst into one of the most controversial questions of our time. What if the Earth is actually flat? Now, before you click away thinking this is just another conspiracy video, I want you to stick with me. Because whether you believe it or not, this idea has captured the imagination of millions of people around the world. And understanding why requires us to journey through ancient civilizations, examine scientific evidence, and explore the very nature of belief itself. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your mind wander through the possibilities we're about to explore. There's absolutely no problem if you drift off halfway through this cosmic journey. Sometimes the most profound truths reveal themselves in the quiet spaces between waking and sleeping. I'd love to know where you're watching from tonight. Drop your location in the comments below. So let's begin this exploration with a simple but profound realization. Right now, as you sit wherever you are, how do you know the Earth is moving? Can you feel it spinning? Can you sense that alleged 67,000 mile per hour journey around the sun? Your immediate experience suggests stillness, stability, a solid foundation beneath you that feels absolutely motionless. This isn't a new observation. For thousands of years, humans looked around and saw exactly what you see now. A flat horizon stretching endlessly in all directions. The sun rising in the east and setting in the west, moving across what appears to be a dome-like sky above a stationary Earth. Water always finding its level, never curving around some invisible sphere. Ships disappearing hull first over the horizon, which flat Earth proponents argue is simply due to perspective and the limitations of human vision, not curvature. Let's travel back in time to understand how this idea shaped human civilization. Picture yourself in ancient Mesopotamia, standing beside the Euphrates River as the sun rises over the endless plains. The Babylonians looked out at their world and saw exactly what made sense. A flat disk floating in a vast ocean, with the heavens arching overhead like a great dome. This wasn't ignorance. This was logical observation based on direct experience. The ancient Egyptians developed elaborate cosmologies around a flat Earth. In their understanding, the world was a rectangular plane with 4 corners, floating on the primordial waters of Nun. The sun god Ra traveled across the sky in his solar bark, bringing light to the flat Earth below before disappearing into the underworld each night. Their pyramids, monuments that required incredible precision and astronomical knowledge, were built by people who believed absolutely in a flat Earth model. Journey with me to ancient China, where scholars and astronomers maintained for millennia that the Earth was flat and square, while the heavens were round. This wasn't primitive thinking. Chinese civilization produced incredible innovations in mathematics, engineering, and astronomy, all while maintaining their flat Earth cosmology. The concept remained virtually unquestioned until European missionaries arrived in the 17th century with their spherical Earth theories. Now, here's where the story gets particularly fascinating. We've been told that medieval Europeans believed in a flat Earth, that Christopher Columbus had to convince everyone the world was round to get funding for his voyage. But this is actually a historical myth, created centuries later to make certain groups appear more enlightened than others. Medieval scholars, influenced by Greek philosophy, generally accepted a spherical Earth. The flat Earth myth was manufactured in the 1600s and popularized in the 1800s as intellectual ammunition in religious and political debates. But let's examine what the ancient Greeks actually discovered, because this is where modern science claims to have definitively proven Earth's spherical nature. Around 500 BCE, Pythagoras proposed that Earth was spherical, not through direct observation, but through philosophical reasoning about perfection and harmony. His student Aristotle later provided what are considered the first scientific arguments for a round Earth. Aristotle pointed to lunar eclipses, noting that Earth's shadow on the moon appeared curved. He observed that different stars were visible from different latitudes. He watched ships disappear hull first over the horizon. These observations, we're told, could only be explained by a spherical Earth. But modern flat Earth proponents argue there are alternative explanations for each of these phenomena that don't require a spinning ball Earth. Then came Eratosthenes, the Greek mathematician who supposedly calculated Earth's circumference around 240 BCE using shadows and geometry. His experiment in Alexandria and Syene is held up as definitive proof of Earth's curvature. But flat Earth researchers argue that his calculations work equally well on a flat Earth model with a local sun, moving in circles above the plane at a relatively close distance. Fast forward to the 1800s, and we encounter Samuel Burley Robotham, a fascinating figure who challenged the spherical Earth narrative that was becoming scientific orthodoxy. Robotham wasn't some uneducated peasant spouting nonsense. He was an educated man who conducted careful experiments along the Bedford Level, a 6-mile straight stretch of water in England. Robotham's experiments were designed to detect Earth's supposed curvature. According to spherical Earth theory, objects should drop below the horizon due to curvature at predictable rates. But Robotham claimed his observations showed no such curvature. He could see objects that should have been hidden behind the curve of the Earth. He published his findings in a book called Zetetic Astronomy, Earth Not a Globe, founding what he called the zetetic method, from the Greek word meaning to seek or to inquire. Critics argue that Robotham failed to account for atmospheric refraction, the bending of light through air of different densities that can make distant objects appear higher than they actually are. But Robotham's work sparked a movement that would persist for generations, attracting followers who believed that direct observation and common sense trumped mathematical theories and institutional authority. The Flat Earth Society, as it came to be known, maintained a modest but persistent presence through the 20th century. Charles K. Johnson led the organization from 1971 until his death in 2001, claiming membership had reached 3,500 people worldwide. Johnson argued that the spherical Earth was a conspiracy perpetuated by governments and space agencies to hide the true nature of our world. But then came the internet age and everything changed. In 2004, Daniel Shenton revived the Flat Earth Society as an online community. What started as a small discussion forum began attracting curious minds from around the world. People who had questions about official narratives, who valued direct observation over theoretical physics, who wondered why we never seem to feel the motion we're told we're constantly experiencing. The modern flat Earth movement exploded in the 2010s, fueled by YouTube videos, online forums, and social media platforms. Suddenly, people who had never heard these ideas before were discovering communities of like-minded individuals asking the same questions they'd wondered about privately. Why can't we see the curvature from airplane windows? Why do ships appear to disappear hull first, if not due to perspective? Why do we need constant course corrections in aviation if we're flying over a spinning sphere? Contemporary flat Earth models vary, but most propose that our world is a circular disk with the Arctic at the center and Antarctica forming an ice wall around the perimeter. The Sun and Moon are described as small, local lights circling above the plane at relatively low altitudes, creating the cycle of day and night through their movements. Gravity, they argue, is either an illusion or replaced by the upward acceleration of the entire Earth plane. These modern flat earthers point to what they see as inconsistencies in official space photography. They question why Earth appears different sizes and colors in various NASA images. They wonder why we can't see stars in space photographs. They ask why space agencies seem to use obvious composites rather than single photographs of the full Earth. The psychological appeal of flat Earth theory extends far beyond the physical evidence debate. In our age of information overload and institutional distrust, the flat Earth model offers something profoundly attractive: a return to direct, personal observation over abstract mathematical concepts that require faith in experts and authorities. Think about it from their perspective. You wake up each morning on what feels like solid, stationary ground. You watch the sun rise and set in predictable patterns. You see water always find its level, never curving around an invisible sphere. You notice that no matter how high you climb or fly, the horizon always appears to rise to eye level, suggesting a flat plane extending indefinitely, rather than the downward curve you'd expect on a ball. Modern flat Earth proponents argue that we've been conditioned to ignore our direct sensory experience in favor of theoretical constructs that serve the interests of powerful institutions. They see the spherical Earth model as part of a larger system of control, designed to make humanity feel small and insignificant on a tiny rock hurtling through an infinite void, rather than special beings living at the center of creation on a stationary, flat plane. This isn't just about geography or astronomy. It's about epistemology, the very foundation of how we determine what's true. Do we trust our senses, our direct experience, our common sense observations? Or do we defer to mathematical models, institutional authorities, and technological instruments that we can't personally verify? The Flat Earth movement represents something deeper than a disagreement about planetary geometry. It's a rebellion against the modern scientific establishment, a return to pre-Copernican thinking that places Earth and humanity at the center of existence, rather than relegated to cosmic insignificance on one planet among billions in a vast, meaningless universe. For Flat Earth believers, this isn't simply an intellectual exercise or academic debate. It's a deeply personal journey of awakening to what they see as humanity's most fundamental deception. Imagine discovering that everything you learned in school, every textbook you studied, every documentary you watched about space exploration was carefully crafted to hide an extraordinary truth about the very ground beneath your feet. The emotional weight of this realization cannot be understated. Picture yourself as someone who has always accepted the spinning ball Earth model without question. You've seen the iconic images of Earth from space, that beautiful blue marble suspended in the cosmic void. You've learned about gravity holding oceans to a rotating sphere, about seasons caused by orbital mechanics, about the vast distances between celestial objects. Then suddenly, you encounter arguments that challenge every single one of these assumptions. The journey often begins with a simple question that lodges itself in someone's mind like an uncomfortable splinter. Why? If Earth is spinning at over 1,000 miles per hour at the equator, do we never feel this motion? Why doesn't the atmosphere get left behind? Why do helicopters hovering in place for hours not find themselves thousands of miles west when they land, having been left behind by a rotating Earth? These questions lead to more questions, each one seemingly reasonable when considered in isolation. If Earth is curved, why can we see distant cities across large bodies of water that should be hidden behind hundreds of feet of curvature? Why do long-distance flights in the southern hemisphere make more sense on a flat Earth map than on a globe? Why do the flight paths themselves seem to follow routes that work perfectly on flat Earth projections, but appear bizarre and inefficient on spherical models? The modern flat Earth researcher doesn't approach these questions with blind faith or willful ignorance. They conduct experiments, analyze data, and apply what they consider to be logical reasoning to observable phenomena. Take the Bedford-level experiments that continue to this day. Contemporary flat earthers use laser levels, high-powered cameras, and sophisticated measuring equipment to test for curvature over bodies of water. When they report seeing no curve where mainstream science predicts significant drop-off due to Earth's supposed spherical shape, they interpret this as direct evidence supporting their model. They point to the Chicago skyline visible from across Lake Michigan at distances where, according to Earth curvature calculations, the entire city should be hidden behind nearly 2,000 feet of curved water. They document ships and oil rigs visible at distances where they should be completely obscured by the horizon. They measure the behavior of water surfaces, arguing that water always seeks its own level and cannot curve around the outside of a spinning sphere. The technological arguments become particularly compelling to those questioning official narratives. Modern flat earthers examine satellite imagery with forensic intensity, claiming to identify digital manipulation, impossible lighting conditions, and composite construction in images presented as single photographs of Earth from space. They question why no space agency has ever produced a single, unedited photograph of the full Earth, despite decades of space exploration and thousands of alleged missions. The International Space Station footage comes under particular scrutiny. Flat Earth researchers analyze hours of ISS video, pointing to what they interpret as wire harnesses, green screen artifacts, and impossible physics in zero-gravity demonstrations. They question why Earth appears flat in much of the ISS footage, why the same cloud formations appear in different locations, and why the supposed 17,500 mile/hour orbital velocity never seems to create the visual effects you'd expect from such incredible speed. NASA becomes a central figure in flat Earth narratives, not necessarily as a villainous organization, but as the primary gatekeeper of information about our world's true nature. Flat Earthers note that NASA receives over $20 billion annually in funding, money that could theoretically support an elaborate production designed to maintain public belief in the spherical Earth model. They point to NASA's own admission that many Earth images are composites, artistic interpretations rather than actual photographs. the space program itself faces intense flat Earth scrutiny. The Van Allen radiation belts, discovered in the 1950s, supposedly contain deadly radiation that would prevent human travel beyond low Earth orbit. Yet we're told that Apollo missions passed through these belts multiple times without significant shielding or apparent harm to astronauts. Flat Earth researchers question how 1960s technology accomplished what seems impossible even today, sending humans safely through deadly radiation fields to land on the moon and return. The moon landings become a crucial piece of the flat Earth puzzle. If humanity never actually left low Earth orbit, if the moon missions were elaborate productions filmed on Earth, then what does this say about our understanding of space and our planet's place within it? The technical challenges of moon travel, the strange behavior of flags and dust in the lunar footage, the impossibility of photographing stars from the lunar surface. All of these elements contribute to flat Earth skepticism about official space narratives. But perhaps the most psychologically powerful aspect of flat Earth theory isn't the physical evidence or technical arguments. It's the sense of empowerment that comes from trusting your own senses over institutional authority. In a world where experts frequently contradict each other, where scientific consensus changes over time, where powerful institutions have documented histories of deception, the flat Earth model offers something appealing: a return to direct observation and common sense reasoning. The social dynamics of flat Earth communities provide something that many people desperately crave in our fragmented modern world: belonging, purpose, and the excitement of being part of something larger than themselves. These aren't isolated individuals spouting random theories. They're organized communities conducting research, sharing findings, and supporting each other in what they see as humanity's most important investigation. The annual Flat Earth conferences draw hundreds of attendees from around the world. These gatherings feature presentations on experimental methodology, analysis of space imagery, discussions of historical cosmology, and testimonials from people who describe their journey from globe believers to flat Earth advocates. The sense of camaraderie and shared mission at these events is palpable. People who felt isolated and confused by their questions about Earth's shape find themselves surrounded by like-minded individuals who share their skepticism and curiosity. The educational backgrounds of flat Earth believers might surprise you. The movement includes engineers, pilots, mathematicians, photographers, and other technically trained individuals who bring professional expertise to their analysis of Earth shape claims. They're not uniformly uneducated or gullible. Many describe themselves as former skeptics who were convinced by evidence rather than ideology. The pilots among them raise particularly interesting questions. Commercial airline pilots undergo extensive training in navigation and flight dynamics. They understand the theoretical principles of flying over a curved Earth, yet some report that their practical flying experience doesn't match what they learned about spherical navigation. They describe flying long distances without needing to adjust for Earth's supposed curvature, maintaining level flight attitudes that should theoretically result in flying off into space if Earth were truly curved below them. The engineers bring technical analysis to flat Earth research, examining the construction of large projects like bridges and railways. Mainstream engineering accounts for Earth's curvature in major construction projects, adding extra length to bridges and adjusting railway grades to accommodate the planet's supposed spherical shape. But flat Earth engineers question whether these adjustments are actually necessary or simply traditional practices based on unverified assumptions about Earth's geometry. The photographers contribute expertise in image analysis, studying space photography and satellite imagery for signs of digital manipulation or impossible lighting conditions. They understand lens distortion, atmospheric effects, and photographic techniques well enough to identify potential problems in official Earth imagery. Their technical knowledge lends credibility to claims about composite construction and artistic enhancement in NASA's Earth photography. This convergence of diverse professional backgrounds creates a robust community of inquiry that extends far beyond simple belief or faith. Flat Earth research involves sophisticated equipment, careful methodology, and rigorous documentation of results. Whether their conclusions are correct or not, the seriousness of their investigation commands a certain respect for their dedication to finding truth through direct observation and analysis. The religious and spiritual dimensions of flat Earth belief add another layer of complexity to the movement. Many flat earthers describe their investigation as a spiritual journey, a return to ancient wisdom traditions that placed Earth at the center of creation. They see the spherical Earth model as part of a broader materialist worldview that reduces humanity to cosmic insignificance, random accidents of evolution on an unremarkable planet in an infinite, meaningless universe. The flat Earth model, by contrast, suggests that Earth is special, unique, possibly the only realm of existence, with humanity occupying a privileged position at the center of creation. This perspective resonates deeply with people who feel lost in the modern world's emphasis on scientific materialism and cosmic insignificance. The flat Earth offers meaning, purpose, and a sense that human existence matters in fundamental ways. Biblical literalists find particular appeal in flat Earth cosmology because it aligns with descriptions of Earth found in ancient scriptures. References to the four corners of the Earth, to the firmament separating waters above from waters below, to the sun and moon as lights in the heavens rather than massive celestial bodies, all of these scriptural elements fit more naturally with flat Earth models than with modern astronomical understanding. The psychological comfort of feeling special, of living at the center of creation rather than on an insignificant speck of dust in a vast empty cosmos, cannot be underestimated as a motivating factor for flat Earth belief. The spherical Earth model places humanity in a context of overwhelming cosmic insignificance. We're told we exist on one planet among billions, in one solar system among trillions, in one galaxy among countless others, all of it expanding into infinite space with no center, no edge, no ultimate meaning or purpose. How different it feels to imagine living on a special plane, carefully designed and maintained, with the sun and moon created specifically to provide light and mark the passage of time for the beings below. This cosmology suggests intentionality, design, purpose, and most importantly, that human existence matters in the grand scheme of reality. The Flat Earth movement also attracts people who have lost faith in institutional authority more broadly. In an era of documented government deception, corporate malfeasance, and academic corruption, the idea that scientific institutions might be perpetuating a fundamental lie about our world doesn't seem impossible. If authorities can lie about wars, medicines, economics, and politics, why not about the shape of the Earth itself? This distrust extends to the entire system of modern education. which flat earthers see as indoctrination rather than genuine learning. From their earliest school years, children learn about the solar system, gravity, and Earth's place in the universe without ever being encouraged to question these concepts or examine the evidence firsthand. The educational system, they argue, creates obedient believers in official narratives rather than critical thinkers capable of independent investigation. The media's role in maintaining spherical Earth belief also comes under flat Earth scrutiny. Every documentary about space, every news report about astronomical discoveries, every children's book about planets reinforces the same basic cosmological assumptions without acknowledging that alternative models exist, or that the evidence for spherical Earth might be less definitive than commonly believed. Flat Earth researchers see themselves as part of an awakening process, helping humanity break free from centuries of conditioning and return to direct observation and independent thinking. They view their work not as spreading false information, but as liberating people from false beliefs that have been imposed through institutional authority rather than discovered through genuine investigation. The scientific establishment's response to flat Earth claims often reinforces believers' suspicions about institutional bias and closed-mindedness. Rather than engaging seriously with flat Earth arguments and evidence, mainstream scientists typically dismiss the entire movement as ignorant conspiracy theorizing, refusing to examine specific claims or address particular pieces of evidence that flat earthers find compelling. This dismissive attitude confirms what flat earthers already suspect: that the scientific establishment is more interested in protecting its authority than in pursuing truth through open investigation. The refusal to debate, to examine evidence, or to acknowledge any validity in flat Earth concerns suggests to believers that mainstream science has something to hide. The flat Earth movement represents something unprecedented in human history: a grassroots challenge to established cosmological authority, organized and amplified through digital communication technologies that allow like-minded individuals to find each other, share research, and coordinate investigation regardless of geographic separation. Never before have ordinary people had such powerful tools for independent research and global communication about alternative theories. This technological empowerment creates new possibilities for challenging institutional knowledge in ways that weren't available to previous generations. Flat Earth researchers can conduct their own experiments, document results with high-quality video, analyze official imagery with sophisticated software, and share findings instantly with global audiences. They don't need institutional approval or academic credentials to participate in cosmological investigation. The movement's growth trajectory suggests that traditional gatekeepers of knowledge may be losing their monopoly on determining what counts as legitimate inquiry into the nature of our world. Whether flat Earth claims prove correct or not, the movement demonstrates that significant numbers of people are willing to question fundamental assumptions about reality and pursue alternative explanations through independent investigation. The implications of this shift extend far beyond questions about Earth's shape. If large numbers of people are willing to challenge basic scientific consensus about planetary geometry, what other supposedly settled questions might be open to reconsideration? The flat Earth phenomenon may represent the beginning of a broader transformation in how knowledge is created, validated, and transmitted in human civilization. The philosophical implications of this shift ripple outward, like stones thrown into still water. When you begin to question something as fundamental as the shape of your own world, every other assumption about reality starts to feel negotiable. The flat Earth movement isn't just challenging geography or astronomy. It's challenging the entire epistemological framework that modern civilization uses to determine truth. Consider the profound psychological journey that someone undergoes when they first seriously entertain flat Earth possibilities. It begins with that initial crack in their worldview, that moment when a familiar assumption suddenly feels uncertain. Maybe they're watching a sunset and wondering why the sun appears to shrink as it moves away rather than maintaining the same size as it supposedly moves behind a curved horizon. Maybe they're on an airplane, looking out the window at what appears to be a perfectly flat landscape extending to the horizon in all directions, with no visible curvature despite being 6 miles above the surface. These moments of doubt create cognitive dissonance, that uncomfortable feeling when our direct experience conflicts with what we've been taught to believe. Most people resolve this dissonance by trusting authority over personal observation. They tell themselves that their senses must be deceiving them, that the experts understand things too complex for ordinary people to grasp. But some individuals choose a different path. They decide to trust their own perception and begin investigating whether their doubts might be justified. This investigation often starts innocently enough. Perhaps they look up the official explanation for why ships disappear hull first over the horizon, or why we can't feel Earth's rotation, or how gravity keeps oceans stuck to a spinning ball. The explanations they find might initially satisfy their curiosity. Atmospheric refraction explains distant visibility. The immense size of Earth makes its rotation imperceptible. Gravity is strong enough to hold everything in place despite rotational forces. But then they encounter alternative explanations that seem equally plausible. Ships disappearing hull first could simply be an optical effect of perspective and atmospheric conditions. The inability to feel Earth's motion might indicate that there is no motion to feel. Water's tendency to remain level might suggest that it actually is level, not curved around a sphere. These alternative explanations don't require complex physics or mathematical formulas. They rely on common sense and direct observation. The appeal of this approach cannot be overstated. In our increasingly complex world, where expertise seems to require decades of specialized education and technological tools beyond most people's reach, the flat Earth model offers something refreshingly accessible. You don't need advanced degrees in physics or astronomy to observe the horizon, to watch the sun's daily path, to notice that water finds its level. The evidence is right there, available to anyone willing to look with fresh eyes. This accessibility creates a powerful sense of empowerment. Instead of feeling dependent on experts and institutions to interpret reality, flat Earth believers discover they can conduct meaningful research using their own senses and simple equipment. They can measure distances across bodies of water, document the visibility of distant objects, analyze photographs and videos for signs of manipulation. The investigation becomes personal, immediate, and authentic in ways that abstract theoretical physics never could. The community aspect amplifies this empowerment. Flat Earth believers don't investigate in isolation. They connect with others who share their questions and doubts, forming networks of mutual support and collaboration. Online forums buzz with reports of new experiments, analysis of official imagery, and discussions of historical evidence. Local groups organize field trips to conduct measurements and observations. Annual conferences provide opportunities for face-to-face meetings and presentations of research findings. These communities develop their own experts, individuals who gain recognition and respect based on the quality of their investigations and the persuasiveness of their arguments. Unlike academic experts whose authority derives from institutional credentials, flat Earth experts earn their status through demonstrated knowledge and successful research. This creates a more democratic and merit-based system of expertise that appeals to people who feel excluded from traditional academic hierarchies. The historical research component of flat Earth investigation adds another fascinating dimension to the movement. Believers don't simply challenge contemporary scientific claims. They also investigate the historical development of spherical Earth theory, looking for evidence that the transition from flat to spherical models was driven more by ideology than by empirical evidence. They examine the motivations of key historical figures, like Copernicus, who proposed the heliocentric model not based on new observations, but as an attempt to simplify astronomical calculations. They question why the Catholic Church initially opposed heliocentrism, if it was obviously true based on available evidence. They investigate the political and religious contexts that may have influenced the adoption of spherical Earth theories during periods of major cultural transformation. This historical investigation reveals that the development of modern cosmology was far messier and more contested than typical educational accounts suggest. The transition from geocentric to heliocentric models wasn't a simple matter of evidence overcoming ignorance. It involved complex interactions between scientific, religious, political, and cultural factors that may have prioritized certain explanations for reasons having little to do with empirical truth. Flat Earth researchers argue that understanding this historical context is crucial for evaluating contemporary scientific claims. If the adoption of spherical Earth theory was influenced by factors beyond pure evidence, then perhaps the theory deserves more critical examination than it typically receives. Maybe the scientific revolution wasn't simply a triumph of reason over superstition, but a more complex transformation that may have discarded valid alternative perspectives along with genuinely problematic beliefs. The technological dimension of flat Earth research continues to evolve as believers gain access to increasingly sophisticated equipment and analytical tools. High-resolution cameras with powerful zoom capabilities allow for observations of distant objects that would have been impossible for previous generations of investigators. Laser levels and surveying equipment enable precise measurements across long distances. GPS technology provides accurate positioning data for field experiments. Computer software allows for detailed analysis of imagery, video enhancement, and sophisticated calculations. Flat Earth researchers use these tools to examine official space photography, looking for inconsistencies in lighting, impossible perspectives, and signs of digital manipulation. They enhance amateur footage of rocket launches, searching for evidence that satellites and space missions may not reach the altitudes claimed by space agencies. The results of these technological investigations often surprise newcomers to flat Earth research. Images that initially appear to show clear evidence of Earth's curvature may reveal signs of digital compositing under closer examination. Rocket launches that supposedly carry payloads to orbit may show trajectories that curve back toward Earth, rather than continuing into space. Satellite imagery may display impossible lighting conditions or repeated cloud formations that suggest artificial construction. These technological findings don't prove flat Earth theory, but they do raise legitimate questions about the reliability of evidence commonly cited to support spherical Earth models. The questions become particularly compelling when mainstream authorities refuse to address them directly, dismissing concerns about imagery, inconsistencies, or technological anomalies without providing satisfactory explanations. The psychological profile of flat Earth believers defies simple stereotyping. While critics often portray them as gullible conspiracy theorists or scientifically illiterate individuals seeking simple answers to complex questions, the reality appears more nuanced. Many flat Earth advocates describe themselves as naturally skeptical people who question official narratives across multiple domains, not just cosmology. They tend to be individuals who value independent thinking over conformity, direct experience over theoretical knowledge, and personal investigation over deference to authority. These characteristics might be seen as positive traits in other contexts, but they lead to conclusions that mainstream society considers problematic when applied to questions about Earth's shape. The conversion stories that flat Earth believers share often follow similar patterns. Most describe themselves as former believers in spherical Earth theory who never question the basic assumptions they learned in school. The transformation usually begins with exposure to flat Earth arguments through online videos, articles, or conversations with friends. Initial reactions are typically skeptical or dismissive, but persistent doubts eventually motivate more serious investigation. The investigation phase varies in duration and intensity, but it generally involves examining both flat Earth claims and mainstream scientific responses. Many describe a gradual shift from skepticism to acceptance as they become more familiar with flat Earth arguments and more critical of official explanations. The final conversion often involves an emotional component, a sense of awakening or liberation from long-held illusions about the nature of reality. These conversion narratives reveal the deeply personal nature of belief change in fundamental worldview questions. Accepting flat Earth theory isn't simply an intellectual exercise. It requires abandoning assumptions that have shaped one's understanding of reality since childhood. Accepting that trusted institutions may be fundamentally deceptive, and embracing a cosmological model that most people consider absurd. The social consequences of flat Earth belief can be severe. Family members and friends often react with concern, dismissal, or ridicule when someone begins expressing doubts about Earth's shape. Professional relationships may suffer if colleagues discover flat Earth beliefs. The broader culture treats flat Earth advocacy as a sign of mental instability or dangerous gullibility rather than legitimate intellectual inquiry. These social pressures create strong incentives to abandon flat Earth beliefs and return to mainstream cosmological acceptance. The fact that many people persist in their flat Earth advocacy despite these pressures suggests that their conviction runs deeper than casual conspiracy theorizing or attention-seeking behavior. They believe they have discovered something important enough to justify the personal costs of their nonconformity. The educational implications of the Flat Earth movement extend beyond questions about planetary geometry. If significant numbers of people are willing to reject basic scientific consensus based on their own investigation and reasoning, this challenges fundamental assumptions about how knowledge should be transmitted in educational systems. Traditional education relies heavily on authority-based learning, where students accept information from teachers and textbooks without conducting independent verification. This approach works efficiently for transmitting established knowledge, but it may not prepare students to think critically about fundamental assumptions or to conduct meaningful independent research on controversial topics. Flat Earth believers argue that their educational experience failed to provide them with the tools and motivation necessary for genuine scientific inquiry. Instead of learning to question assumptions and design experiments, they learn to memorize and repeat official explanations. Instead of developing confidence in their own observational abilities, they learn to defer to expert authority, even when it conflicted with direct experience. This critique of educational methodology resonates beyond flat Earth communities. Many educators and students recognize that contemporary schooling often emphasizes compliance and memorization over critical thinking and independent investigation. The Flat Earth movement represents an extreme response to these educational limitations, but it may highlight genuine problems with how scientific knowledge is taught and learned. The media's role in shaping public understanding of cosmological questions also comes under scrutiny from flat Earth perspectives. Every nature documentary, science program, and news report about space exploration reinforces the same basic assumptions about Earth's shape and humanity's place in the universe. Alternative perspectives receive little or no coverage except as objects of ridicule or concern. This media uniformity creates an environment where spherical Earth theory appears obviously true simply because no credible alternatives are ever presented for public consideration. People grow up immersed in spherical Earth imagery and explanations without ever encountering serious challenges to these ideas. When they eventually discover flat Earth arguments, the contrast with their media-shaped expectations can be jarring and compelling. Flat Earth believers argue that true scientific progress requires open debate and consideration of alternative hypotheses, not the suppression of dissenting views through ridicule and institutional pressure. They see media uniformity on cosmological questions as evidence of coordinated deception rather than scientific consensus based on overwhelming evidence. The technological capabilities that enable modern flat Earth investigation also raise broader questions about the democratization of knowledge creation. Traditional scientific research required access to expensive equipment, specialized training, and institutional support. These barriers naturally limited participation in cosmological investigation to a small number of credentialed experts working within established institutions. Today's technology eliminates many of these barriers. High-quality cameras, measurement tools, and analytical software are available to ordinary consumers at affordable prices. The internet provides instant access to vast amounts of information and enables global collaboration among researchers regardless of institutional affiliation. Social media platforms allow for rapid dissemination of findings and theories without traditional gatekeeping mechanisms. These technological changes create new possibilities for scientific investigation outside institutional frameworks. Whether this democratization leads to better understanding of natural phenomena or increased confusion and misinformation remains an open question. The Flat Earth movement demonstrates both the potential benefits and risks of enabling widespread participation in scientific inquiry. The movement's growth trajectory suggests that institutional authority over cosmological questions may be weakening, regardless of whether flat Earth claims prove valid. Large numbers of people are demonstrating willingness to conduct independent research, challenge expert consensus, and form alternative communities of knowledge creation. This trend extends beyond flat Earth theory to include questioning of medical recommendations, climate science claims, historical narratives, and other domains traditionally dominated by institutional expertise. The long-term implications of this shift remain unclear. Increased public participation in scientific investigation could lead to important discoveries and corrections of institutional errors. Alternatively, it could result in widespread acceptance of false beliefs and rejection of valid scientific knowledge. The outcome may depend largely on how institutions respond to challenges from grassroots research communities. The relationship between institutional science and grassroots investigation reveals something profound about how human beings construct and maintain their understanding of reality. When we step back and examine this dynamic objectively, we begin to see that the conflict isn't really about the shape of Earth at all. It's about something much more fundamental: the question of who gets to determine what counts as legitimate knowledge in human civilization. Consider the remarkable fact that we're even having this conversation in the 21st century. Flat Earth theory was supposedly settled centuries ago, relegated to the dustbin of discredited ideas alongside spontaneous generation and phlogiston theory. Yet here we are, witnessing a genuine renaissance of interest in cosmological models that mainstream science considers absurd. This resurgence didn't happen in a vacuum. It emerged from specific conditions in our contemporary culture that made alternative explanations suddenly seem plausible to significant numbers of people. The digital revolution created unprecedented opportunities for information sharing and community building around unconventional ideas. Before the internet, someone with doubts about Earth's shape might encounter a few like-minded individuals in their lifetime, if any. Today, they can instantly connect with thousands of others who share their questions and concerns. This connectivity transforms isolated doubts into organized movements with their own research programs, conferences, and social structures. But technology alone doesn't explain the flat Earth phenomenon. The movement also reflects deeper tensions in contemporary society about truth, authority, and the nature of expertise itself. We live in an era when institutional credibility has been severely damaged by documented deceptions, corruption scandals, and spectacular failures of expert judgment. When people lose faith in institutions generally, it becomes easier to question even their most fundamental claims. The psychological appeal of flat Earth theory extends beyond distrust of authority. The model offers something that spherical Earth cosmology cannot: a sense of living in a comprehensible human-scaled world where direct observation provides reliable guidance about the nature of reality. Modern astronomy presents us with a universe so vast and strange that it exceeds human capacity for intuitive understanding. We're told we exist on a tiny speck orbiting one star among hundreds of billions in a galaxy that's one of trillions, expanding through infinite space at incomprehensible speeds. This cosmic perspective, while scientifically compelling, creates what philosophers call existential vertigo. Human consciousness struggles to find meaning and purpose in such overwhelming immensity. The flat Earth model, by contrast, suggests we live in a special place designed specifically for human habitation. with the sun and moon created to provide light and mark time for the beings below. This cosmology offers psychological comfort that spherical Earth theory simply cannot match. The experimental methodology that flat Earth researchers employ deserves serious consideration regardless of their conclusions. Many of their experiments are genuinely clever attempts to test fundamental assumptions about our world using direct observation and simple equipment. The Bedford-level experiments, for instance, represent a straightforward approach to detecting Earth's supposed curvature by observing distant objects across bodies of water. Whether atmospheric refraction explains their results or not, the experimental logic is sound. Modern flat Earth investigators have expanded these techniques using contemporary technology. They employ high-powered cameras with sophisticated zoom capabilities to observe distant objects that should be hidden behind Earth's curvature. They use laser levels to test for the drop-off that spherical Earth theory predicts over long distances. They analyze official imagery using professional-grade software to look for signs of digital manipulation or impossible lighting conditions. The results of these investigations often surprise even skeptical observers. Distant cities remain visible across bodies of water at distances where hundreds of feet of curvature should hide them completely. Objects maintain their apparent size and clarity at ranges where atmospheric distortion should render them invisible. Official space imagery reveals inconsistencies and anomalies that raise legitimate questions about how these images were created. These empirical findings don't necessarily prove flat Earth theory, but they do suggest that our understanding of observational phenomena may be less complete than commonly assumed. The refusal of mainstream science to engage seriously with these observations reinforces flat Earth suspicions about institutional close-mindedness and the suppression of inconvenient evidence. The historical dimension of flat Earth research reveals another compelling aspect of the movement. Believers don't simply challenge contemporary scientific claims, they also investigate the historical development of spherical Earth theory itself. This investigation uncovers a more complex and contested history than most people realize. The transition from flat to spherical Earth models wasn't a simple triumph of evidence over ignorance. It involved intricate interactions between scientific, religious, political, and cultural factors that may have influenced theoretical development in ways having little to do with empirical truth. The timing of major cosmological shifts often coincided with broader cultural transformations that created incentives for adopting new worldviews. The heliocentric revolution occurred during periods of religious reformation and political upheaval, when challenging established authority became culturally advantageous. The rapid acceptance of evolutionary theory followed similar patterns, gaining prominence during eras when progressive ideologies were ascendant in intellectual circles. This historical context raises important questions about the relationship between scientific development and social dynamics. If major theoretical changes were influenced by factors beyond pure empirical evidence, then perhaps these theories deserve more critical examination than they typically receive. Maybe the scientific revolution involved discarding some valid insights, along with genuinely problematic beliefs. Flat Earth researchers argue that understanding this historical complexity is crucial for evaluating contemporary scientific claims. They suggest that the scientific establishment has developed vested interests in maintaining certain theoretical frameworks, regardless of their empirical adequacy. Billions of dollars in research funding, entire academic careers, and powerful institutional structures depend on the continued acceptance of current cosmological models. This creates what philosophers of science call paradigm lock-in, where theoretical frameworks become so entrenched that contradictory evidence gets ignored or explained away, rather than prompting serious reconsideration of fundamental assumptions. The history of science includes numerous examples of important discoveries being initially rejected because they conflicted with established paradigms, from continental drift to bacterial causes of ulcers. The Flat Earth movement may represent an attempt to break free from such paradigm lock-in by returning to direct observation and independent investigation. Whether their specific conclusions prove correct, their methodological approach of questioning fundamental assumptions and conducting independent research reflects important scientific values that institutional science sometimes struggles to maintain. The psychological profiles of flat Earth believers continue to defy simple stereotyping. Research suggests that many are well-educated individuals with technical backgrounds who bring professional expertise to their cosmological investigations. Engineers analyze the construction requirements for large projects, questioning whether Earth curvature corrections are actually necessary or simply traditional practices based on unverified assumptions. Pilots examine their flight experiences, wondering why practical aviation doesn't seem to require the constant adjustments that spherical Earth navigation should demand. Photographers and videographers contribute expertise in image analysis, studying space photography for signs of digital manipulation or impossible lighting conditions. Computer specialists examine the technical aspects of satellite imagery and space mission footage, looking for artifacts that might indicate artificial construction rather than authentic documentation of space exploration. This convergence of diverse professional backgrounds creates research communities with genuine technical competence, not just naive enthusiasm for conspiracy theories. Their investigations may reach questionable conclusions, but the methodological sophistication they bring to their work commands respect for their seriousness and dedication. The spiritual and philosophical dimensions of flat Earth belief add layers of meaning that extend far beyond questions of planetary geometry. Many believers describe their investigation as a journey of spiritual awakening, a return to ancient wisdom traditions that recognized Earth as special and central rather than cosmically insignificant. This perspective resonates with people who feel alienated by modern materialism and its implications for human meaning and purpose. The spherical Earth model, embedded within contemporary scientific cosmology, presents human existence as a cosmic accident occurring on an unremarkable planet in an infinite, purposeless universe. This worldview may be scientifically accurate, but it offers little comfort to people seeking meaning, purpose, and significance in their lives. The Flat Earth model, by contrast, suggests that human existence matters fundamentally, that our world is unique and specially designed, that consciousness and life represent central features of reality rather than temporary aberrations in a hostile cosmos. Religious believers find particular appeal in Flat Earth cosmology because it aligns with scriptural descriptions of Earth and humanity's place in creation. Biblical references to the firmament, the four corners of the Earth, and the sun and moon as lights in the heavens fit more naturally with Flat Earth models than with modern astronomical understanding. This concordance between ancient texts and contemporary alternative cosmology provides additional motivation for questioning spherical Earth theory. The social dynamics within flat Earth communities reveal another important aspect of the movement's appeal. These communities provide belonging, purpose, and mutual support for people who often feel isolated by their unconventional beliefs. Members describe finding acceptance and understanding among fellow researchers that they can't get from family, friends, or colleagues who dismiss their cosmological concerns. The annual conferences and local meetups create opportunities for face-to-face interactions that strengthen community bonds and provide platforms for sharing research findings. These gatherings feature presentations on experimental methodology, analysis of official imagery, discussions of historical evidence, and personal testimonies from individuals describing their journey from spherical to flat Earth beliefs. The educational sessions at these events often demonstrate impressive technical knowledge and investigative skills. Presenters use sophisticated equipment, detailed measurements, and careful analysis to support their arguments. Whether their conclusions prove valid, their methodological approach reflects genuine scientific thinking rather than simple conspiracy theorizing. The media treatment of flat Earth communities typically focuses on the most extreme claims and colorful personalities, rather than examining the substance of their arguments or the sophistication of their investigations. This selective coverage reinforces public perceptions of flat Earth believers as scientifically illiterate conspiracy theorists, while ignoring evidence that many are thoughtful, technically competent individuals with legitimate questions about fundamental assumptions. The dismissive approach that mainstream institutions take toward flat Earth research may actually strengthen the movement by confirming believers' suspicions about institutional close-mindedness and the suppression of dissenting views. When respected scientists refuse to examine flat Earth evidence or engage with their arguments, it suggests to believers that mainstream science has something to hide rather than overwhelming evidence to defend. This dynamic creates a self-reinforcing cycle where institutional dismissal breeds increased suspicion, leading to more intensive flat Earth investigation, which produces additional findings that institutions continue to ignore, further confirming believers' conviction that they're uncovering suppressed truths about reality. The technological trajectory of flat Earth research continues advancing as believers gain access to increasingly sophisticated equipment and analytical capabilities. High-resolution cameras now enable observations of distant objects that previous generations of investigators couldn't attempt. Precision measurement tools allow for accurate testing of curvature predictions across extended distances. Computer software enables detailed analysis of imagery and video that can reveal subtleties invisible to casual observation. These technological capabilities are democratizing scientific investigation in ways that challenge traditional gatekeeping mechanisms. Ordinary individuals can now conduct research that was previously limited to institutional scientists with access to expensive equipment and specialized facilities. This democratization creates new possibilities for discovery and error correction, but it also enables the rapid spread of false conclusions based on flawed methodology or misinterpreted results. The Flat Earth movement demonstrates both the potential benefits and risks of this technological democratization. On one hand, it shows how determined individuals can conduct serious investigations using accessible tools and techniques. On the other hand, it illustrates how sophisticated-seeming research can lead to conclusions that contradict well-established scientific knowledge. the long-term implications of this trend extend far beyond cosmological questions. If significant numbers of people are willing to reject fundamental scientific consensus based on independent investigation, this could herald a broader transformation in how knowledge gets created and validated in human civilization. Traditional institutions may lose their monopoly on determining legitimate scientific truth as grassroots research communities gain credibility and influence. The outcome of this transformation remains uncertain. Increased public participation in scientific investigation could lead to important discoveries and corrections of institutional errors. Alternatively, it could result in widespread acceptance of false beliefs and rejection of valid scientific knowledge. The balance may depend largely on how institutions respond to challenges from grassroots research communities and whether they can maintain credibility while addressing legitimate concerns about transparency and accountability. The flat Earth phenomenon represents a fascinating case study in the sociology of knowledge, demonstrating how alternative explanations can gain traction when institutional authority weakens and technology enables new forms of community organization and investigation. Whether flat Earth theory proves correct or not, the movement reveals important truths about human psychology, social dynamics, and the complex relationships between evidence, belief, and authority in contemporary society. As we continue to navigate an era of increasing skepticism toward institutional expertise and growing access to tools for independent investigation, understanding movements like Flat Earth becomes crucial for anyone interested in how human beings construct and maintain their understanding of reality. The questions they raise about evidence, authority, and the nature of truth extend far beyond cosmology to touch the foundations of how we know what we know about our world. The implications ripple outward through every domain of human knowledge and social organization, challenging us to reconsider fundamental assumptions about expertise, education, and the relationship between individual observation and collective understanding. In this light, the Flat Earth movement becomes more than just an interesting curiosity or concerning delusion. It becomes a window into the deep structures of human knowledge-making and the forces that shape our collective understanding of reality itself. Making and the forces. Into the deep structures of human knowledge that shape our collective understanding of reality itself. The scientific response to Flat Earth claims reveals another fascinating layer of this contemporary phenomenon. When mainstream scientists encounter Flat Earth arguments, their reactions often follow predictable patterns that inadvertently reinforce believers' suspicions about institutional bias and closed-mindedness. Rather than engaging with specific experimental findings or addressing particular pieces of evidence that Flat Earth researchers consider compelling, the scientific establishment typically responds with broad dismissals and appeals to authority. They point to centuries of established knowledge, the consensus among experts, and the successful applications of spherical Earth theory in technology and engineering. These responses, while technically accurate, miss something crucial about the psychological and social dynamics driving Flat Earth belief. They fail to acknowledge that for many believers, the issue isn't simply about planetary geometry. It's about the fundamental question of how we determine what's true in a world where institutional authority has been repeatedly compromised by deception, corruption, and spectacular failures of expert judgment. Consider the position of someone who has spent months or years investigating Flat Earth claims with genuine intellectual curiosity. They've conducted experiments, analyzed imagery, studied historical records, and connected with communities of like-minded researchers. When they present their findings to mainstream scientists, hoping for serious engagement and substantive responses, they're often met with ridicule, dismissal, or condescending lectures about basic physics. This treatment confirms their suspicions that the scientific establishment is more interested in protecting its authority than pursuing truth through open investigation. It suggests that mainstream science operates more like a religious orthodoxy than a system of inquiry genuinely committed to following evidence wherever it leads. The refusal to examine flat Earth evidence directly, to replicate their experiments, or to address specific anomalies they've documented appears to believers as evidence that mainstream science cannot actually refute their claims through empirical investigation. If the evidence for spherical Earth were as overwhelming as claimed, why wouldn't scientists welcome opportunities to demonstrate this through direct engagement with flat Earth challenges? This dynamic creates a paradoxical situation where scientific dismissal strengthens flat Earth conviction rather than undermining it. Each refusal to engage seriously with their research confirms believers' narrative about institutional suppression of inconvenient truths. Each appeal to authority reinforces their conviction that mainstream science relies more on social pressure than empirical evidence. The educational implications extend beyond individual belief formation to broader questions about how scientific knowledge gets transmitted across generations. Traditional science education relies heavily on authority-based learning, where students accept information from teachers and textbooks without conducting independent verification or developing the skills necessary for critical evaluation of fundamental assumptions. This approach works efficiently for transmitting established knowledge, but it may leave students unprepared to think critically about controversial claims or to conduct meaningful independent research. When people educated in this system encounter alternative theories like flat Earth, they often lack the tools necessary for evaluating the claims on their merits, rather than simply deferring to institutional authority. Flat Earth believers argue that their educational experience failed to provide them with genuine scientific literacy. Instead of learning to question assumptions, design experiments, and follow evidence regardless of its implications for established beliefs, they learned to memorize and repeat official explanations without developing confidence in their own observational and analytical abilities. This critique resonates with broader concerns about educational methodology that many teachers and students recognize as legitimate problems in contemporary schooling. The emphasis on standardized testing, compliance with curriculum requirements, and preparation for college admissions often comes at the expense of developing critical thinking skills and scientific curiosity. The Flat Earth movement represents an extreme response to these educational limitations, but it highlights genuine issues with how scientific knowledge gets taught and learned. Students who develop real scientific literacy should be able to evaluate alternative theories, identify flawed reasoning, and design experiments to test competing hypotheses. The fact that many educated people find flat Earth arguments initially compelling suggests that traditional science education may not be developing these capabilities effectively. The role of technology in enabling and amplifying flat Earth research continues evolving as new tools become available to amateur investigators. Drone technology now allows for aerial observations from perspectives that were previously impossible for non-professional researchers. High-definition video capabilities enable detailed documentation of experimental procedures and results. GPS technology provides precise positioning data for field investigations. Computer analysis tools continue advancing, allowing for increasingly sophisticated examination of imagery, video, and datasets. Machine learning algorithms could potentially identify patterns or anomalies in large collections of space photography that human analysts might miss. Virtual reality technology might eventually allow for immersive simulation of different cosmological models, helping people visualize and compare the implications of spherical versus flat Earth theories. These technological developments will likely continue expanding the capabilities of grassroots research communities, while also providing new tools for both supporting and challenging flat Earth claims. The democratization of sophisticated analytical capabilities creates unprecedented opportunities for independent investigation, but it also increases the potential for generating convincing but misleading evidence based on technological artifacts or methodological errors. The international dimensions of the Flat Earth movement reveal interesting patterns about how alternative ideas spread across different cultural and educational contexts. While the movement originated primarily in English-speaking countries with strong internet connectivity, it has expanded to include participants from diverse cultural backgrounds and educational systems worldwide. The universal appeal of questioning fundamental assumptions about reality transcends specific cultural contexts, suggesting that the psychological and social factors driving flat Earth belief operate across different societies and educational traditions. People from various backgrounds report similar conversion experiences. Initial skepticism, followed by gradual acceptance as they conduct their own investigations and connect with flat Earth communities. This global spread also enables cross-cultural validation of flat Earth claims and experiments. Researchers from different countries can replicate each other's observations, providing additional confidence in their findings, while reducing the likelihood that results are artifacts of local conditions or methodological biases specific to particular investigators. The linguistic diversity within international flat Earth communities creates interesting dynamics around translation and interpretation of technical concepts and experimental results. Ideas that originated in English must be adapted for different languages and cultural contexts, potentially introducing subtle variations in meaning and emphasis that could influence how the theories develop in different regions. The economic dimensions of flat Earth research and community building deserve attention as the movement continues growing and attracting commercial interest. Annual conferences generate significant revenue from registration fees, vendor booths, and related services. Online platforms monetize flat Earth content through advertising, subscription services, and merchandise sales. This commercialization creates both opportunities and potential problems for the movement. On one hand, economic incentives enable more sophisticated research, better produced educational materials, and expanded outreach capabilities. Professional conference organizers can create higher quality events that attract larger audiences and more credible speakers. On the other hand, commercial interests may distort research priorities and community dynamics in ways that prioritize entertainment value or audience engagement over rigorous investigation. Content creators might emphasize sensational claims over careful methodology if dramatic presentations generate more views and revenue than careful analysis. The tension between maintaining intellectual integrity and appealing to popular audiences affects many areas of science communication, but it becomes particularly acute in controversial fields like flat Earth research, where participants often feel they're fighting against institutional suppression and public ridicule. The psychological research on conspiracy belief provides additional context for understanding flat Earth appeal, though believers typically reject characterizations of their views as conspiracy theories. Academic studies suggest that conspiracy beliefs often serve important psychological functions, providing sense-making frameworks for confusing or threatening events, creating feelings of special knowledge and insight, and fostering community connections with like-minded others. These psychological benefits don't necessarily invalidate the substantive claims that conspiracy believers make, but they do suggest that people might be motivated to accept conspiracy explanations for reasons beyond pure evidence evaluation. The psychological satisfaction of possessing secret knowledge, of being part of an enlightened minority that sees through widespread deception, can be compelling enough to influence how people interpret ambiguous evidence. Flat Earth believers generally resist these psychological explanations, arguing that their conclusions result from careful investigation rather than emotional needs or cognitive biases. They point to the technical sophistication of their research, the diversity of their professional backgrounds, and the consistency of their experimental results as evidence that their beliefs reflect genuine discoveries rather than psychological wishful thinking. This debate about the relative importance of psychological versus empirical factors in belief formation extends far beyond flat Earth theory to encompass broader questions about human rationality and the social construction of knowledge. How much do our beliefs reflect objective evaluation of evidence, and how much do they serve psychological and social functions that may bias our interpretation of information? The answer likely varies among individuals and situations, but the question remains crucial for understanding how people form beliefs about controversial topics where evidence is ambiguous or conflicting. Flat Earth believers may be right that their conclusions reflect genuine discoveries, or critics may be right that psychological factors are distorting their interpretation of evidence. Determining which explanation fits the facts requires careful analysis of both the empirical claims and the psychological dynamics involved. The media coverage of flat Earth phenomena reveals another layer of complexity in how alternative ideas get presented to broader public audiences. Mainstream media treatment typically focuses on the most extreme claims and colorful personalities within the movement, while ignoring the more sophisticated research and measured arguments that many believers find most compelling. This selective coverage serves several functions for media organizations. It generates audience interest through novelty and controversy, while maintaining clear boundaries between legitimate and illegitimate knowledge claims. By presenting flat Earth believers as obviously deluded individuals making absurd assertions, media coverage reinforces mainstream scientific authority without requiring detailed engagement with alternative arguments. However, this approach may backfire by creating sympathy for flat Earth believers who feel misrepresented and stereotyped by media coverage that ignores the substance of their concerns. People who encounter actual flat Earth arguments may find them more reasonable than media portrayals suggested, leading to increased interest in investigating the claims independently. The documentary films and extended media coverage that treat flat Earth claims more seriously often reveal the complexity and thoughtfulness that casual media reports obscure. These longer-form presentations show believers as articulate, technically knowledgeable individuals with genuine concerns about fundamental assumptions, rather than simplistic conspiracy theorists spouting obvious nonsense. This more nuanced coverage helps explain why flat Earth ideas continue attracting new adherents, despite widespread ridicule and institutional opposition. When people encounter the actual arguments and evidence that believers find compelling, rather than caricatured versions presented in dismissive media reports, they may find the alternative explanations more plausible than they expected. The relationship between flat Earth belief and broader patterns of institutional distrust reflects deeper currents in contemporary political and social dynamics. The movement emerges during a period when faith in expert authority has been shaken by documented failures and deceptions across multiple domains, from medical recommendations to economic predictions to intelligence assessments. This erosion of institutional credibility creates opportunities for alternative explanations to gain traction among people who might previously have deferred to official authorities without question. When institutions lose their presumptive credibility, their claims must compete in a more open marketplace of ideas, where success depends more on persuasive evidence and compelling arguments than on institutional status. Flat Earth theory benefits from this changed environment because it offers clear, testable predictions that people can evaluate through their own observation and investigation. Unlike many areas where expert knowledge requires years of specialized training to evaluate meaningfully, basic questions about Earth's shape seem accessible to ordinary intelligence and common sense reasoning. The movement also benefits from broader cultural trends toward individualism and skepticism of collective authority that encourage people to trust their own judgment over social consensus. In a culture that celebrates independent thinking and personal empowerment, the flat Earth message of trusting direct observation over abstract theoretical constructs resonates with widely shared values. The scientific method itself becomes a contested concept within these debates, with flat Earth believers arguing that their approach represents more authentic scientific thinking than the authority-based acceptance that characterizes much contemporary scientific practice. They claim to follow evidence wherever it leads, regardless of its implications for established beliefs, while mainstream science allegedly suppresses inconvenient findings to protect institutional interests. This methodological debate reveals fundamental tensions about what constitutes legitimate scientific inquiry and who gets to participate in knowledge creation. Traditional science relies heavily on specialized training, peer review, and institutional gatekeeping to maintain quality standards and prevent the proliferation of false beliefs. But these same mechanisms can also suppress genuine discoveries that challenge established paradigms or threaten institutional interests. The democratization of research tools and communication technologies creates new possibilities for conducting and disseminating scientific investigation outside traditional institutional frameworks. Whether this leads to improved understanding or increased confusion depends partly on how successfully alternative research communities can develop effective quality control mechanisms and how receptive established institutions prove to be toward external challenges and corrections. The future trajectory of the Flat Earth movement remains uncertain as it continues evolving in response to technological developments, cultural changes, and institutional reactions. The movement could potentially fragment into multiple competing factions with different theoretical emphases and methodological approaches. It might gradually decline as initial enthusiasm wanes and believers move on to other interests. Or it could continue growing and developing more sophisticated research programs that pose increasingly serious challenges to mainstream cosmological consensus. The institutional response will likely play a crucial role in determining which of these outcomes occurs. Continued dismissal and ridicule may strengthen the movement by confirming believers' narratives about institutional bias and suppression. More serious engagement with flat Earth claims and evidence could either refute them convincingly or reveal genuine problems with established theories that require correction. The broader implications extend far beyond questions about planetary geometry to encompass fundamental issues about knowledge, authority, and democracy in technological societies. How should democratic societies handle situations where significant numbers of citizens reject expert consensus on important factual questions? What obligations do institutions have to engage with alternative theories and grassroots research communities? How can societies maintain beneficial forms of epistemic authority while remaining open to necessary corrections and improvements? These questions become increasingly urgent as technology continues democratizing access to research tools and communication platforms, while simultaneously making it easier to create convincing but false evidence through digital manipulation and selective presentation. The flat Earth phenomenon may represent just the beginning of a broader transformation in how human societies construct and maintain shared understanding of reality. The educational system faces particular challenges in preparing people to navigate this changing epistemic landscape. Students need skills for evaluating competing claims, designing meaningful experiments, and thinking critically about fundamental assumptions. But they also need appreciation for the value of expertise, institutional knowledge, and collaborative inquiry that has produced humanity's greatest intellectual achievements. Balancing these competing needs requires educational approaches that develop both critical thinking skills and epistemic humility, both confidence in personal observation and respect for collective wisdom, both skepticism toward authority and recognition of the benefits that legitimate expertise provides. The Flat Earth movement, regardless of its factual accuracy, offers valuable lessons about the consequences of failing to achieve this balance effectively. As we stand at this crossroads between traditional authority-based knowledge systems and emerging forms of democratized investigation, the Flat Earth phenomenon serves as a fascinating case study in the complex dynamics that shape human understanding. It reveals both the remarkable human capacity for independent thinking and investigation, and the potential dangers of rejecting accumulated wisdom without adequate replacement frameworks. The movement challenges us to examine our own assumptions about truth, evidence, and authority, while remaining committed to the careful reasoning and empirical investigation that have proven so valuable for expanding human knowledge and capability. Whether Flat Earth believers prove right or wrong about planetary geometry, their passionate commitment to questioning fundamental assumptions and conducting independent research embodies important scientific values that deserve respect and careful consideration. In the end, the Flat Earth phenomenon may teach us as much about ourselves and our knowledge-making processes as it does about the shape of our world. It reveals the deep human need for meaning, community, and agency in determining what counts as truth, while highlighting the ongoing challenges of maintaining both intellectual freedom and collective wisdom in rapidly changing technological and social environments. The story continues unfolding as new evidence emerges, new technologies develop, and new generations of investigators join the ongoing conversation about the nature of our world and our place within it. Whatever conclusions future research may reach, the questions raised by the Flat Earth movement will likely continue resonating through broader discussions about science, democracy, and the fundamental nature of human knowledge itself. The personal testimonies of individuals who have embraced Flat Earth theory reveal a complex tapestry of human experience that defies simple categorization. These aren't abstract philosophical debates happening in ivory towers. They're deeply personal journeys that reshape how people understand their place in existence itself. Meet Sarah, a former high school physics teacher who spent 15 years explaining orbital mechanics and gravitational theory to teenagers. She describes her transformation as gradual, beginning with questions about why students struggle to reconcile textbook explanations with their direct observations. When a student asked why we can't feel Earth's rotation, Sarah found herself giving the standard explanation about Earth's size, making the motion imperceptible. But something about the student's skeptical expression lingered in her mind. That evening, Sarah found herself standing in her backyard, watching the sunset with fresh eyes. For the first time in years, she noticed how the sun appeared to shrink as it moved away across the sky, rather than maintaining constant size as it supposedly disappeared behind a curved horizon. The observation unsettled her in ways she couldn't immediately articulate. It was such a simple thing, but it contradicted everything she thought she understood about perspective and distance. The doubt that took root that evening grew slowly over months. Sarah began conducting informal experiments during her lunch breaks, using surveying equipment borrowed from the school's engineering department to measure sight lines across the local lake. The results consistently showed no detectable curve where her calculations predicted significant drop-off due to Earth's supposed spherical shape. Each measurement deepened her confusion and sparked new questions. The transformation accelerated when Sarah discovered online communities of people asking similar questions. She found engineers, pilots, photographers, and other technically trained individuals sharing detailed analyses of everything from space photography to aircraft navigation. These weren't the scientifically illiterate conspiracy theorists she had expected. They were thoughtful, methodical researchers conducting sophisticated investigations into fundamental assumptions about reality. The social cost of Sarah's evolving beliefs proved devastating. Colleagues who had respected her expertise began treating her with concern and embarrassment. The school administration grew uncomfortable with her questions about curriculum content. Parents complained when word spread about her unconventional views. Eventually, Sarah felt compelled to resign from her teaching position rather than continue facing professional ostracism and institutional pressure. But Sarah describes this period not as a loss, but as liberation from what she now sees as an elaborate system of intellectual conformity. She speaks passionately about rediscovering the joy of independent investigation, of trusting her own senses and reasoning rather than deferring to institutional authority. Her flat Earth advocacy represents more than cosmological belief. It embodies a fundamental shift toward valuing personal experience over collective consensus. Similar stories emerge from across the Flat Earth community. Mark, a commercial airline pilot with 25 years of flying experience, describes growing discomfort with the disconnect between his practical navigation experience and the theoretical principles he learned in training. He noticed that long-distance flights seemed to follow routes that made perfect sense on flat Earth projections, but appeared inefficient and bizarre when plotted on globular maps. During flights across the Pacific, Mark observed that aircraft maintain level flight attitudes without needing constant downward adjustments that spherical Earth navigation should require. The autopilot systems that maintain altitude and heading don't seem to account for the curved surface that pilots are taught to expect. These observations accumulated over years until Mark could no longer ignore their implications for his understanding of Earth's true shape. The professional consequences for Mark were less severe than Sarah's experience, partly because airline protocols discourage public discussion of controversial topics by crew members. But Mark describes feeling intellectually isolated among colleagues who either hadn't noticed the same discrepancies or chose not to discuss them openly. The silence surrounding these observations convinced Mark that institutional pressures were preventing honest examination of evidence that contradicted official narratives. Jennifer's journey into flat Earth belief began through her work as a professional photographer, specializing in landscape and architectural imagery. Her technical expertise in optics, lighting, and image composition led her to notice anomalies in official space photography that troubled her professional sensibilities. Impossible lighting conditions, inconsistent shadows, and obvious signs of digital compositing appeared throughout NASA's supposedly authentic documentation of space exploration. The analysis that convinced Jennifer involved examining hundreds of Earth images released by various space agencies over decades. She applied the same forensic techniques she used to detect manipulation in commercial photography, looking for telltale signs of artificial construction, impossible perspectives, and technical inconsistencies that indicated composite creation rather than single exposure photography. Her findings revealed patterns that seemed to confirm systematic manipulation of space imagery to maintain public belief in spherical Earth models. Cloud formations appeared identical in different images supposedly taken months apart. Lighting angles defied the physics of solar illumination. Continental proportions varied dramatically between images that claimed to show the same planetary features from similar distances and angles. Jennifer's expertise in digital imaging made these discrepancies impossible to ignore or explain away through appeals to atmospheric effects or equipment limitations. Her professional reputation for detecting photographic fraud gave weight to her conclusions about space imagery manipulation, attracting attention from other technically trained individuals who shared her concerns about institutional deception. The pattern that emerges from these personal narratives reveals something profound about the nature of belief change in fundamental worldview questions. The conversion process typically begins with a moment of cognitive dissonance, when direct experience conflicts with accepted explanations in ways that create persistent doubt. This initial crack in the worldview foundation gradually widens as individuals encounter alternative explanations that seem to resolve the contradictions more satisfactorily than official accounts. The social dimensions of this transformation prove crucial for sustaining belief change in the face of widespread opposition and ridicule. Isolated individuals might abandon their doubts under social pressure, but connection with communities of like-minded researchers, provides validation and support for continuing investigation despite external hostility. The shared experience of questioning fundamental assumptions creates bonds that extend beyond cosmological beliefs to encompass broader skepticism toward institutional authority and conventional wisdom. The research methodologies that these communities develop often demonstrate genuine scientific sophistication despite their controversial conclusions. Flat Earth investigators employ controlled experiments, statistical analysis, and peer review processes that mirror traditional scientific practices. They document their procedures carefully, share raw data openly, and subject their findings to critical evaluation by community members with relevant technical expertise. The annual conferences showcase this methodological sophistication through presentations that feature detailed experimental protocols, sophisticated equipment, and careful analysis of results. Speakers present findings on atmospheric optics, surveying techniques, image analysis, and historical research using professional quality visual aids and technical terminology that demonstrates deep engagement with their subject matter. The quality of discourse at these events often surprises observers who expect to encounter obvious pseudoscience and conspiracy theorizing. Instead, they find thoughtful individuals engaged in serious intellectual work, asking probing questions about fundamental assumptions and designing clever experiments to test competing hypotheses about the nature of reality. This methodological competence makes flat Earth claims more difficult to dismiss than critics often acknowledge. While their conclusions may prove incorrect, their investigative approaches often reflect genuine scientific thinking rather than simple conspiracy theorizing or wishful thinking. The movement attracts people who value empirical evidence and logical reasoning, even when these lead to conclusions that contradict mainstream scientific consensus. The educational backgrounds and professional credentials of prominent flat Earth researchers further complicate attempts to characterize the movement as scientifically illiterate conspiracy theorizing. The community includes individuals with advanced degrees in engineering, physics, mathematics, and other technical fields who bring legitimate expertise to their cosmological investigations. These credentialed researchers face particularly severe professional consequences for their flat Earth advocacy, risking career advancement and institutional standing to pursue what they consider honest investigation of fundamental questions. Their willingness to sacrifice professional security for intellectual integrity suggests deeper motivations than attention-seeking or simple gullibility. The institutional response to credentialed flat Earth researchers reveals interesting dynamics about how scientific establishments handle dissent from within their own ranks. Rather than engaging with the substance of their arguments, institutions typically respond with concern about mental health, professional competence, or institutional reputation. This deflection from empirical questions to personal character assessments reinforces flat Earth suspicions about suppression of inconvenient evidence. The technological evolution of flat Earth research continues advancing as believers gain access to increasingly sophisticated analytical tools and measurement equipment. High-resolution cameras with extreme zoom capabilities now enable observations that were impossible for previous generations of investigators. Precision surveying instruments allow for accurate testing of curvature predictions across distances that span entire continents. Computer analysis capabilities continue expanding, enabling detailed examination of vast collections of imagery and data that would overwhelm human analytical capacity. Machine learning algorithms could potentially identify subtle patterns or anomalies in official space documentation that human investigators might miss. Virtual and augmented reality technologies might eventually allow for immersive comparison of different cosmological models, helping people visualize the implications of spherical versus flat Earth theories. These advancing capabilities create new opportunities for both supporting and challenging flat Earth claims through increasingly sophisticated investigation. The democratization of advanced analytical tools continues eroding traditional barriers between institutional and grassroots research, enabling ordinary individuals to conduct investigations that rival professional scientific work in technical sophistication. The international expansion of flat Earth research creates additional opportunities for cross-validation of experimental results across different geographic and cultural contexts. Researchers from various countries can replicate each other's observations, reducing the likelihood that findings reflect local conditions or methodological biases specific to particular investigators or regions. The linguistic diversity within global flat Earth communities creates interesting dynamics around translation and interpretation of technical concepts and experimental procedures. Ideas that originated in English-speaking contexts must be adapted for different languages and cultural frameworks, potentially introducing variations in emphasis and meaning that could influence how theories develop in different regions. The economic dimensions of flat Earth research and community building continue evolving as the movement attracts commercial interest and develops revenue streams through conferences, media production, and educational materials. This commercialization enables more sophisticated research and outreach capabilities, while potentially creating incentives that could distort investigative priorities in favor of entertainment value over rigorous methodology. The psychological research on belief formation and change provides additional context for understanding flat Earth appeal and persistence, though believers typically resist characterizations that emphasize emotional or social factors over empirical evidence. Academic studies suggest that fundamental worldview changes often involve complex interactions between cognitive, emotional, and social processes that extend beyond simple evidence evaluation. The media treatment of flat Earth phenomena continues evolving as journalists and documentary filmmakers develop more nuanced approaches to covering the movement. While mainstream coverage often focuses on sensational claims and colorful personalities, longer-form investigations increasingly reveal the complexity and thoughtfulness that characterize much flat Earth research. The relationship between flat Earth belief and broader patterns of institutional skepticism reflects deeper cultural currents that extend far beyond cosmological questions. The movement emerges during a period when traditional forms of epistemic authority face unprecedented challenges from democratized information technologies and widespread documented failures of expert judgment across multiple domains. The scientific establishment's response to flat Earth challenges reveals important tensions about the nature of legitimate scientific inquiry and the role of institutional gatekeeping in maintaining knowledge quality. Traditional peer review and credentialing systems serve important functions in preventing the proliferation of false beliefs, but they may also suppress genuine discoveries that challenge established paradigms or threaten institutional interests. The democratization of research capabilities creates new possibilities for advancing human understanding, while also increasing the potential for generating convincing but misleading conclusions based on methodological errors or selective evidence presentation. The Flat Earth movement demonstrates both the promise and peril of this technological transformation in knowledge creation and validation. The future trajectory of Flat Earth research remains uncertain as the movement continues developing in response to technological advances, cultural changes, and institutional reactions. The community could potentially evolve toward greater methodological sophistication and empirical rigor, or it might fragment into competing factions with different theoretical emphases and investigative approaches. The broader implications for democratic societies become increasingly urgent as technology continues enabling alternative research communities, while simultaneously making it easier to create convincing but false evidence through digital manipulation and selective presentation. The challenge of maintaining beneficial forms of epistemic authority while remaining open to necessary corrections and improvements requires careful balance between respect for expertise and openness to external challenges. The educational implications extend beyond individual belief formation to encompass fundamental questions about how democratic societies should prepare citizens to evaluate competing knowledge claims in an era of increasing epistemic democratization. Students need skills for critical thinking and independent investigation, while also developing appreciation for the value of institutional knowledge and collaborative inquiry. The Flat Earth phenomenon, regardless of its factual accuracy, offers valuable insights into the complex dynamics that shape human understanding and the ongoing challenges of maintaining both intellectual freedom and collective wisdom in rapidly changing technological and social environments. The questions it raises about evidence, authority, and the nature of knowledge itself will likely continue resonating through broader discussions about science, democracy, and human understanding for generations to come. As we witness this remarkable chapter in the history of human inquiry, we're reminded that the most fundamental questions about our world and our place within it remain open to investigation, debate, and discovery. Whether Flat Earth researchers ultimately prove right or wrong about planetary geometry, their passionate commitment to questioning assumptions and pursuing independent investigation embodies values that have always driven human progress and understanding. The story continues unfolding as new evidence emerges, new technologies develop, and new generations join the ongoing conversation about the nature of reality itself. In this grand investigation of existence, every perspective contributes something valuable to our collective understanding, even when conclusions prove incorrect. The journey of inquiry itself, with all its twists and revelations, remains one of humanity's most noble and essential endeavors. Tonight, as you contemplate these profound questions about the nature of our world, remember that you too are part of this ancient tradition of human curiosity and investigation. Whether you find yourself drawn to conventional explanations or alternative theories, the act of questioning itself connects you to countless generations of seekers who have gazed up at the same stars and wondered about the deepest mysteries of existence. The universe, in whatever form it takes, continues revealing its secrets to those brave enough to ask difficult questions and follow the evidence wherever it leads. And in that pursuit of truth, regardless of where it ultimately takes us, we find something profound about what it means to be human in a cosmos full of wonder, mystery, and endless possibilities for discovery. discovery. The philosophical implications of this entire phenomenon extend into territories that challenge our most basic assumptions about reality, truth, and human knowledge itself. As we drift deeper into contemplation of these cosmic questions, we find ourselves confronting something far more profound than mere disagreements about planetary geometry. Consider the extraordinary position we occupy as conscious beings trying to understand the very ground beneath our feet. Here we are, temporary arrangements of atoms that somehow became aware, attempting to comprehend the nature of the realm that birthed us into existence. The Flat Earth movement, regardless of its ultimate validity, represents something remarkable about human consciousness. Our refusal to accept reality passively, our insatiable drive to question, investigate, and seek truth through our own experience. The epistemological crisis that Flat Earth theory reveals cuts to the heart of how we determine what counts as legitimate knowledge in human civilization. When you strip away the specific claims about ice walls and dome-shaped skies, what remains is a fundamental tension between two different approaches to understanding reality. On one side stands the institutional model, where knowledge flows from credentialed experts through established channels to passive recipients who accept information based on authority rather than personal verification. On the other side emerges a grassroots model where individuals trust their own senses, conduct independent investigations, and form communities of inquiry based on shared curiosity rather than institutional affiliation. This tension isn't new in human history, but it's being amplified and transformed by technological capabilities that our species has never possessed before. For the first time, ordinary individuals have access to tools and communication platforms that enable sophisticated investigation and global collaboration without institutional gatekeeping. A person with curiosity and determination can now conduct research that rivals professional scientific work in technical sophistication, document their findings with broadcast-quality video, and instantly share results with audiences that span the entire planet. The psychological dimensions of this transformation reveal something profound about human nature itself. We are meaning-seeking creatures, desperate to understand our place in the cosmic order and our significance within the grand narrative of existence. The spherical Earth model embedded within contemporary scientific cosmology presents us with a universe of overwhelming scale and apparent purposelessness, where human consciousness emerges as a temporary accident on an insignificant speck of rock orbiting an ordinary star in an unremarkable galaxy among countless others expanding through infinite empty space. This cosmological perspective, while scientifically compelling, creates what philosophers describe as existential vertigo. The human mind struggles to find meaning and purpose in such vast, impersonal immensity. We evolved to navigate human-scaled environments with clear boundaries, recognizable patterns, and comprehensible cause and effect relationships. The modern scientific worldview asks us to accept a reality that exceeds our cognitive capacity for intuitive understanding, requiring faith in mathematical abstractions and theoretical constructs that we can never directly experience or verify. The Flat Earth model offers something psychologically precious, a return to human-scaled cosmology, where direct observation provides reliable guidance about reality's nature. Instead of feeling lost in infinite space, believers can imagine themselves living on a special plane designed specifically for conscious beings, with celestial lights arranged to provide illumination and mark the passage of time for the creatures below. This perspective suggests intentionality, design, and most importantly, that human existence matters fundamentally, rather than representing a cosmic accident of no particular significance. The social dynamics within flat Earth communities provide something equally precious: genuine intellectual fellowship among people who share profound questions about reality's basic structure. These aren't casual social gatherings or hobby clubs. They're communities of serious inquiry, where individuals support each other in what they consider humanity's most important investigation. Members describe finding acceptance and understanding among fellow researchers that they cannot get from family, friends, or colleagues who dismiss their cosmological concerns as obvious delusions. The technical sophistication that characterizes much flat Earth research challenges easy dismissal of the movement as simple ignorance or conspiracy theorizing. Contemporary believers employ precision measurement tools, high-resolution imaging equipment, and sophisticated analytical software to test fundamental assumptions about planetary geometry. They document their experimental procedures with scientific rigor, share raw data openly, and subject their findings to critical evaluation by community members with relevant technical expertise. The annual conferences showcase this methodological sophistication through presentations featuring detailed experimental protocols, professional quality visual aids, and technical discussions that demonstrate deep engagement with complex observational and theoretical questions. Attendees include engineers, pilots, photographers, mathematicians, and other professionally trained individuals who bring legitimate expertise to their cosmological investigations. This convergence of technical competence and controversial conclusions creates fascinating tensions within broader scientific and educational communities. How should institutions respond when technically trained individuals use sophisticated methodologies to reach conclusions that contradict fundamental scientific consensus? The typical response involves appeals to authority, social pressure, and professional sanctions, rather than direct engagement with the empirical claims and experimental evidence that believers find most compelling. The historical research component of flat Earth investigation adds another layer of complexity to the movement's intellectual foundations. Believers don't simply challenge contemporary scientific claims. They also investigate the historical development of spherical Earth theory itself, looking for evidence that major cosmological transitions were driven by factors beyond pure empirical evidence. They examine the social, political, and religious contexts that may have influenced theoretical adoption during periods of cultural transformation. They question whether the scientific revolution represented a simple triumph of evidence over superstition, or a more complex process that may have discarded valid insights, along with genuinely problematic beliefs. This historical investigation reveals that the development of modern cosmology involved messier and more contested processes than typical educational accounts suggest. The technological trajectory of flat Earth research continues advancing as believers gain access to increasingly powerful analytical capabilities. Machine learning algorithms could potentially identify subtle patterns in vast collections of space imagery that human investigators might miss. Virtual reality systems might enable immersive comparison of different cosmological models, helping people visualize the implications of competing theories about reality's basic structure. These advancing capabilities create new opportunities for both challenging and supporting flat Earth claims, through ever more sophisticated investigation. The democratization of advanced analytical tools continues eroding traditional barriers between institutional and grassroots research, enabling individuals to conduct investigations that rival professional scientific work in technical complexity and methodological rigor. The international expansion of the movement creates additional opportunities for cross-validation of experimental results across different geographic, cultural, and linguistic contexts. Researchers from various countries can replicate each other's observations, reducing the likelihood that findings reflect local conditions or methodological biases specific to particular investigators or regions. The economic dimensions of flat Earth research and community building continue evolving as the movement develops revenue streams through conferences, educational materials, and media production. This commercialization enables more sophisticated research capabilities while potentially creating incentives that could prioritize entertainment value over rigorous methodology. The media treatment of flat Earth phenomena continues developing as journalists and documentary filmmakers create more nuanced coverage that reveals the complexity and thoughtfulness characterizing much of the movement's investigative work. While mainstream reporting often focuses on sensational claims and colorful personalities, longer-form investigations increasingly show believers as articulate, technically competent individuals with legitimate concerns about fundamental assumptions rather than simple conspiracy theorists. The relationship between flat Earth belief and broader patterns of institutional distrust reflects deeper cultural currents that extend far beyond cosmological questions. The movement emerges during an era when traditional forms of epistemic authority face unprecedented challenges from democratized information technologies and documented failures of expert judgment across multiple domains. The scientific establishment's response to flat Earth challenges reveals important tensions about the nature of legitimate inquiry and the role of institutional gatekeeping in maintaining knowledge quality. Traditional credentialing and peer review systems serve crucial functions in preventing the proliferation of false beliefs, but they may also suppress genuine discoveries that challenge established paradigms or threaten institutional interests. The democratization of research capabilities creates new possibilities for advancing human understanding, while also increasing potential for generating convincing but misleading conclusions based on methodological errors or selective evidence presentation. The flat Earth phenomenon demonstrates both the promise and peril of this technological transformation in knowledge creation and validation processes. The educational implications extend beyond individual belief formation to encompass fundamental questions about how democratic societies should prepare citizens to evaluate competing knowledge claims in an era of increasing epistemic democratization. Students need skills for critical thinking and independent investigation, while also developing appreciation for the value of institutional knowledge and collaborative inquiry that has produced humanity's greatest intellectual achievements. The future trajectory remains uncertain as the movement continues developing in response to technological advances, cultural changes, and institutional reactions. The community could evolve toward greater methodological sophistication and empirical rigor, or it might fragment into competing factions with different theoretical emphasis and investigative approaches. The broader implications for democratic societies become increasingly urgent as technology continues enabling alternative research communities while simultaneously making it easier to create convincing but false evidence through digital manipulation and selective presentation. The challenge of maintaining beneficial forms of epistemic authority while remaining open to necessary corrections and improvements requires delicate balance between respect for expertise and openness to external challenges. As we stand at this crossroads between traditional authority-based knowledge systems and emerging forms of democratized investigation, the flat Earth phenomenon serves as a fascinating case study in the complex dynamics shaping human understanding. It reveals both the remarkable capacity for independent thinking and investigation and the potential dangers of rejecting accumulated wisdom without adequate replacement frameworks. The movement challenges us to examine our own assumptions about truth, evidence, and authority, while remaining committed to careful reasoning and empirical investigation that have proven valuable for expanding human knowledge and capability. Whether flat Earth believers prove correct about planetary geometry, their passionate commitment to questioning fundamental assumptions and conducting independent research embodies important values that deserve respectful consideration. The personal testimonies of transformation continue revealing the deeply human dimensions of this cosmological controversy. These aren't abstract philosophical debates occurring in academic settings. They're profound personal journeys that reshape how individuals understand their existence and place within the cosmic order. The psychological courage required to embrace beliefs that invite ridicule and social ostracism suggests motivations deeper than attention-seeking or simple gullibility. Many flat Earth advocates sacrifice professional standing, family relationships, and social acceptance to pursue what they consider honest investigation of reality's fundamental nature. The community bonds forged through shared investigation of these ultimate questions create relationships that extend far beyond casual interest in alternative theories. Members describe finding intellectual fellowship and emotional support among fellow researchers that provides meaning and purpose, often missing from conventional social interactions. The spiritual dimensions of flat Earth belief add additional layers of significance that extend beyond questions of planetary geometry. Many believers describe their investigation as a journey of spiritual awakening, a return to cosmological perspectives that recognize Earth and humanity as special and central rather than cosmically insignificant. This spiritual component resonates with people seeking meaning and purpose in a materialistic culture that often reduces human existence to biological accidents occurring on an unremarkable planet in a purposeless universe. The flat Earth model suggests that consciousness and life represent central features of reality rather than temporary aberrations in an hostile cosmos. The relationship between ancient wisdom traditions and contemporary alternative cosmology provides additional motivation for questioning modern scientific orthodoxy. Scriptural references to firmaments, corners of the earth, and celestial lights as luminaries, rather than massive distant objects, align more naturally with flat Earth models than with conventional astronomical understanding. The technological empowerment that enables contemporary flat Earth research represents something unprecedented in human history. Ordinary individuals using sophisticated tools to investigate fundamental questions about reality's nature without requiring institutional permission or approval. This democratization of knowledge creation challenges traditional gatekeeping mechanisms while creating new possibilities for both discovery and error. The global reach of digital communication platforms allows like-minded investigators to find each other regardless of geographic separation, forming international communities of inquiry that transcend cultural and linguistic boundaries. This connectivity transforms isolated doubts into organized movements with research programs, educational initiatives, and social structures that provide alternatives to conventional institutional frameworks. And so, as we reach the end of this extraordinary journey through one of humanity's most provocative questions, we find ourselves not with definitive answers, but with something perhaps more valuable: a deeper appreciation for the magnificent complexity of human curiosity itself. Whether the earth beneath your feet rests on a vast plain or spins as a sphere through infinite space, tonight you've witnessed something remarkable about our species. The relentless drive to question, to investigate, to refuse easy answers when direct experience whispers different truths. The flat Earth phenomenon reveals as much about the nature of knowledge, belief, and human community as it does about planetary geometry. In our quest to understand the shape of our world, we've discovered profound insights about the shape of human understanding itself. Sweet dreams, fellow seekers. And remember that in a universe full of mysteries, the greatest discovery may simply be our capacity to wonder at all.